Good morning. In this video I am going to discuss about tension member. So tension member means you can see here directly in the figure. A tension member is a member which transmits a direct axial load pulled between two joints in a structural frame. So you can see the two types of structural frame in the diagram. So first one is truss frame and another one is square frame. So here I given some examples for tension members like cables, flat plates, angle section and gusset plate. So what are the major type of tension member means it look like angles, channels and T's, and it will be a closed section like circular, square and rectangular hollow section, and build up section also will be there like double angles, double channels, and built section like four angle members are also called as tension members. So you can see ties are there and in the truss member, so this is known as the tension member. So here you can see a tension member is connected with some plates and welder connections and angle sections. So note two bolt when you are connecting, some reduction factors will be there. So even when we are designing the shear strength of bolt, you discuss it in a very elaborated manner when in the class I asked about the bolts. So here you can see 2 bolt reduction factor is 0.6 and 3 bolt reduction factor is 0.7 and 4 bolt reduction factor is 0.8. So one design example I came up with one design example. So in the design example you can see a single angle with 125 mm into 75 mm and 10 mm as a tension member with a longer leg of the angle is connected to the gusseted plate with 5 bolts of 20 mm dia. So determine the net effective area of the angle alternately if the end of the longer leg of the angle are welded to the gusset plate. So here they are asking net effective area. Whenever tension member is there, they will ask you to do how to find out the net effective area. So you can see here two plate will be there as 125 mm and 75 mm connected with one small angle with 5 bolts of 20 mm dia. So in this I am going to find out the effective net area. To find out net effective area, you need to know what is effective net area and the net area of the angle. So before I am going to find out the effective net area, so you need to find out what is the net area of the connector leg. So you can see I given in the first point, net area of the connector leg is equal to gross area minus area of bolt holes minus half area of the web into T. So gross area is total 122 minus 22 into 5. Why? Because here total 125 mm dia, 125 mm length. So all over length is 125. So you have to deduct with your 5 bolts of 20 mm dia. So already I explained. So when you are coming to all over D, small d plus t, so 20 plus 2, 22. So that 22 minus 5 into 10 thickness. So total is 980 mm square. So net area of the connector leg is 980 mm square. To find out the area of the outstanding leg, gross area minus half area of the web into T. So gross area is 75 minus 5 into 10, 700 mm square. And finally the net area of the angle is combination of net area of connected leg plus area of the outstanding leg. So 980 plus 700, 1680 mm square. And finally the effective net area is equal to alpha, that means alpha into the net area of the angle. So in previously I explained, here reduction factors will be there. So 4 bolt 0.8, so here it is 5 bolt more than 4, that's the reason 0.8. So 0.8 into 1680, so finally 1244 mm square, since it is 5 bolt, reduction factor is 0.8. So when the angle is welded to the gusset plate, so here two conditions, one is when the angle is bolted to the gusset plate and another one is welded to the gusset plate. So when it is bolted to the gusset plate, it is net effective area is 1244 mm square, and when it is welded to the gusset plate, you can see, so net area of the connector leg, again we are doing the same procedure, and finally you need to find out the net area of the angle. Here net area of the angle is 1200 plus 700. So area of the outstanding leg is same for both cases, for gusset plate also with bolted and gusset plate also with welded. So only the thing is changes in area of outstanding leg due to that is bolted and this is welded. So finally the net area of the angle for the gusset plate is 1900 mm square. So final effective net area is equal to gamma, that means reduction factor into net area of angle. So here the reduction factor is 0.8 due to 5 bolts and 20 mm dia. So 0.8 into 1900, so finally 1520 mm square. Since the angle leg is welded due to the gusset plate, so you can see the difference. So how much difference it is coming. So bolted connection it will be different and welded connection it will be different. So about steel structure, what I need to say means, so when we are starting from the starting of the session from the CO, so materials, bolted connection, welded connection, then simple connection, eccentric connection, moment connection, tension members, compression members. So all the cases with the different types of probability, if you solve the problem, you will understand clearly what it is ongoing in steel structure. So it is not like DS is like detailed from starting to the step 1 to until step 10, finding out the reinforcement details, 4 bars like that. No, so it will be like finding out the shear bolt, strength of the bolt, so strength of the plate, everything, and check the combination of torsion and shear. That's it. So it will be complete in very easy manner. Only the thing is understanding the concept with the different variation of materials, bolted, welded, and everything. So that's all for today's. So still, if you have any doubts, you can ask in the normal class or in the tutorial session. Thank you for listening.